Dear members of the jury, welcome to this presentation. My name is Vannel Zeufack, and I am a second-year graduate student at Kennesaw State University in the field of computer science. So during the last summer, I have been working on developing a preprocessing bundle for HPCC systems machine learning library. So indeed, the current version of the HPCC systems machine learning library does contains a wide range of machine learning algorithms, but it lacks modules and functions allowing machine learning engineers to easily prepare their data sets for machine learning algorithms. So to fill that gap, we developed a preprocessing bundle, which currently contains two modules for handling datasets containing categorical features, two other modules for scaling data, and then a function for normalizing data, and then two other functions for splitting the dataset. So the sample dataset you see on the poster will be used to describe each of the functions and modules in the preprocessing bundle. So starting with the label encoder, so it allows to convert categorical features into unique numbers starting from 0. It has three main functions: get key, encode, and decode. So encoding and decoding are based on the key, and the key contains the categories for each of our categorical features. So the little code snippet below shows how the functions are called, and then you have the result on top here, where you have the key containing your categories, and then you have the result of the encoding below, where you no more have the labels for the feature 1 and feature 2, which were initially high, low, medium, and blue, red, blue. Now you have numbers instead. So following the label encoder, we will discuss quickly about the to-fill function macro, which is not really part of the module, but all the remaining modules and functions are partially dependent on this macro. So this macro allows you to convert a record-oriented dataset like our sample dataset into a cell-oriented numeric field dataset like this one. So a numeric field dataset is the record structure used by all the machine learning algorithms in the HPCC machine learning library. So once you have a numeric field dataset, so you can split your dataset using the split function or the stratify split function. You will provide the data and then the training size or the test size. So if you want to maintain the proportions of one of your features, you can use stratify split and specify the index of that feature. So this code snippet is just a sample to show how those functions could be called. So you could also perform one-hot encoding. In the case you have categorical features with no ordering relationship, like in feature 2, you have blue and red, and you don't really want any of them to be considered as higher than the other. So one-hot encoding will create new binary features for each of the category in the categorical features. It has three main functions and a constructor. So the constructor takes as parameters some data from which the categories will be extracted, and then the feature list, in this case the indexes of your features, and then the key. If you already built the encoder before, then you will only pass the key without passing the base data or the feature list. So you also have a get key function to get the categories, and then you have an encode function and a decode function as well. So this little code snippet is just to show how the module could be created and called for encoding, for one hot encoding the data. So you have a result here on encoding the training data after splitting. So you could also scale the data using min-max scaler or standard scaler. Min-max scaler will allow you to shift your data set into a range, min-max range, while standard scaler will allow you to shift your data into a such that they have a zero mean and a unit variance. So both the min-max scaler and the standard scaler have three main functions: get key, scale, and onscale. The min-max scaler constructor takes as parameter some base data from which the minimums and maximum will be extracted, and then mean value and maximum value, which defaults to 0 and 1. And then standard scaler takes as parameter some base data and then a key if you already built the standard scaler. So on top here you have the little code snippet showing how you could call each of these modules. Finally, you have the normalize function, which allows you to normalize your data set based either on the L1 norm, L2 norm, or L infinity norm. And you have this little code snippet showing how you could call the ML normalize function. So below you have the result among all the scaling, so among min-max scaler and ML normalize, just this is the result after normalizing the data set. So this is basically the result after you have prepared your data set using most of our machine learning preprocessing bundle algorithms. So currently we are outsourcing our code to programmers such that they give us feedback, and then the vision of this is to grow this bundle such that it fits all the users and then help them accelerate the data preparation phase of their machine learning projects. So we are waiting for your feedback, and then thanks for listening.